In this video, we will discuss about important questions, answers for Eigen Values and Eigen Vectors. Find the Eigen Values and Eigen Vectors of the matrix A equals to 8, minus 6, 2, minus 6, 7, minus 4, 2, minus 4, 3. The characteristics matrix is given by A minus lambda I, which is equals to, from the above A matrix, the characteristics matrix is given by 8 minus lambda minus 6, 2 minus 6, 7 minus lambda minus 4, 2 minus 4, 3 minus lambda. The characteristics polynomial is given by determinant of this matrix, that of A minus lambda I, which is given by 8 minus lambda times 7 minus lambda into 3 minus lambda minus 4 into 4 is 16 minus of minus 6 is plus 6 into minus 6 into 3 minus lambda plus 8 plus 2 into 24 minus 2 into 7 minus lambda, which is equals to 0. By solving, which is equals to 8 minus lambda into 21 minus 10 lambda plus lambda square minus 16 plus 6 into 18 minus 18 plus 6 lambda plus 8 plus 2 into 24 minus 14 plus 2 lambda is equals to 0, which is equals to 8 minus lambda into 5 minus 10 lambda plus lambda square plus 6 into 6 lambda minus 10 plus 2 into 10 plus 2 lambda equals to 0. By solving this equation, 40 minus 80 lambda plus 8 lambda square minus 5 lambda minus plus 10 lambda square minus lambda cube plus 36 lambda minus 60 plus 20 plus equals to 0, minus, which is equals to minus lambda cube plus 18 lambda square minus 45 lambda equals to 0. Therefore lambda cube minus 18 lambda square plus 45 lambda is equals to 0. Therefore the lambda values are lambda is equals to 15, 3, 0. These are the three eigenvalues. Therefore, for corresponding each lambda value, for lambda equals to 15, now the corresponding characteristics matrix is given by 8 minus 15 minus 6 2 minus 6 7 minus 15 minus 4 2 minus 4 3 minus 15. This matrix will be solved, which is minus 7 minus 6 2 minus 6 minus 8 minus 4 2 minus 4 minus 12. R2 implies 7R2 minus 6R1 and R3 implies 7R3 plus 2R1. Then this matrix will be, the row 1 will be as it is 7 6 minus 2 0 20 and 40 0 40 and 80. Now R3 implies R3 minus 2R2 row 1 will be as it is 7 6 minus 2, row 2 will be 0 20 40, row 3 is 0 0 0. Since the rank of the matrix R is 2 and the order of the matrix is 3, n equals to 3 and R equals to 2. Therefore n minus R is equals to 3 minus 2 is equals to 1. Means one eigenvector is corresponding to this eigenvalue. Let x3 equals to k. The first equation is 7x1 plus 6x2 minus 2x3 is equals to 0. The second equation is 20x2 plus 40x3 is equals to 0. Now here if substituting the value of x3, 20x2 is equals to minus 40k, x2 is equals to minus 2k. Now substituting the value of x1, x2 and x3 in the first equation, 7x1 minus 12k minus 2k is equals to 0. Therefore 7x1 is equals to 14k, x1 is equals to 2k. Therefore corresponding eigenvector x1 is equals to 2k minus 2k and k is equals to k into 2 minus 2 and 1. For corresponding to the eigenvalue of lambda equals to 3, 8 minus 3 minus 6 2 minus 6 7 minus 3 minus 4 2 minus 4 3 minus 3. Therefore corresponding matrix is 5 minus 6 2 minus 6 4 minus 4 2 minus 4 0. By using row transformations, R2 implies R2 by minus 2 and R3 implies R3 by 2. The matrix will be, row 1 will be as it is, R2 implies 5R2 minus 3R1 and R3 implies 5R3 minus R1. Row 1 will be as it is, 5 minus 6 2. Here is 0 8 and 4 0 4 and 2. Now R3 implies 2R3 minus R2. The matrix will be, row 1 will be as it is, 5 6 and 2. Row 2 will be as it is, row 3 will be 0 0 0. Hence rank of this matrix is 2. Is R equals to 2 and the order of the matrix n is equals to 3. N minus R is equals to 3 minus 2, which is equals to 1. One eigenvector is corresponding to this value. Now let x3 is equals to k. Now the first equation is 5x1 minus 6x2 plus 2x3 is equals to 0. And the second equation is 8x2 minus plus 4x3 is equals to 0. Now from the second equation, 8x2 plus 4k equals to 0. Therefore x2 is equals to minus 4 by 8k, which implies x2 is equals to minus 1 by 2k. Now substituting this value of x2 and x3 in the first equation, we can obtain 5x1 minus 6 into minus 1 by 2k plus 2k is equals to 0. This minus 1 it will be plus and it will be 6 by 2 will be 3. Therefore 5x1 plus 3k plus 2k is equals to 0. Therefore x1 is equals to minus k. The eigenvectors capital X2 is equals to minus k by 2 k minus 1 by 2 1. 8 6 2 minus 6 7 minus 4 2 minus 4 3. By doing row transformations, R2 implies 4R2 plus 3R1 and R3 implies 4R3 minus R1. Matrix will be, row 1 will be as it is. Here R3 implies the quadratic form is given by 3x square plus 5y square plus 3z square minus 2yz plus 2zx minus 2xy. The symmetric matrix is obtained. Here x square coefficient is 3, whereas xy coefficient is minus 2 and xz coefficient is plus 2. Now for these coefficients, for xy coefficient, yz coefficient and xz coefficient, you will divide with 2. Then the corresponding symmetric matrix A is equals to 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. Now for this symmetric matrix, we will find the characteristic matrix. Characteristics matrix is given by A minus lambda by equals to 3 minus lambda minus 1 1 minus 1 5 minus lambda minus 1 1 minus 1 3 minus lambda. Now to find out characteristic equation, we'll find out the determinant of this matrix. Determination of A minus lambda I equals to 3 minus lambda into 5 minus lambda into 3 minus lambda minus 1 plus 1 into minus 1 into 3 minus lambda plus 1 plus 1 into 1 minus 5 minus lambda equals to 0, which is equals to 3 minus lambda into 15 minus 5 lambda minus 3 lambda plus lambda square minus 1 plus 1 into lambda minus 2 plus 1 into lambda minus 4 equals to 0. Lambda square minus 24 lambda plus 42 minus lambda cube plus 8 lambda square minus 14 lambda plus lambda minus 2 plus lambda minus 4 is equals to 0, minus lambda cube plus 11 lambda square minus 36 lambda plus 36 is equals to 0. Therefore, lambda cube plus 11 lambda square plus 36 lambda minus 36 is equals to 0. By solving this equation, you can find out the values of lambda. Lambda equals to 2, 3, 6. Now for lambda equals to 2, now we can find out the values of corresponding is eigen value. We will find out the values of eigen vectors. Now substituting in the characteristics matrix, you can have 3 minus 2 minus 1 1 minus 1 5 minus 2 minus 1 1 minus 1 3 minus 2. Therefore, this matrix will be 1 minus 1 1 minus 1 3 minus 1 1 minus 1 1. Now R2 implies R2 plus R1 and R3 implies R3 minus R1. This will be row 1 will be as it is 0 2 0 0 0 0. Then the matrix rank of the matrix A is less than number of unknowns, and n minus r is equals to 3 minus 2 equals to 1. Now let z is equals to k. Now the first equation is x minus y plus z equals to 0. The second equation is 2y is equals to 0. From this y equals to 0. Now substituting the values of z and y in the first equation, x minus 0 as k is equals to 0. Therefore x is equals to minus k. And corresponding, therefore eigenvectors are x1 is equals to xy z equals to minus k 0 k. If you take common k into minus 1 0 1. For second lambda equals to 3. Characteristics matrix A is equals to 3 minus 3 minus 1 1 minus 1 5 minus 3 minus 1 1 minus 1 3 minus 3. Therefore A is equals to 0 minus 1 1 minus 1 2 minus 1 1 minus 1 0. R3 double implies R1 A is equals to 1 minus 1 0 minus 1 2 minus 1 0 minus 1 1. Now R2 implies R2 plus R1. Therefore A is equals to 1 minus 1 0 0 0 1 minus 1 0 minus 1 1. Now R3 implies R3 plus R2. A is equals to 1 minus 1 0 0 1 minus 1 0 0 0. Therefore the rank of the matrix A is equals to 2 and n equals to 3. R equals to the rank of matrix equals to 2 and n equals to 3. Therefore the value of n minus r is 1. Therefore one eigenvector is corresponding to this eigenvalue from this matrix. X minus y is equals to 0. First one. Second one is y minus z equals to 0. Let z is equals to k. Therefore y minus k is equals to 0. Y equals to k. Now substitute in the first equation. X minus k is equals to 0. X equals to k. Therefore x equals to k, y equals to k, and z equals to k. Then corresponding eigenvectors are x, y, z are k, k, and k, which is equals to k into 1 1 1. Now corresponding to the eigen value lambda equals to 6. A minus lambda is equals to 3 minus 6 minus 1 1 minus 1 5 minus 6 minus 1 1 minus 1 3 minus 6. Which is equals to minus 3 minus 1 1 minus 1 minus 1 minus 1 1 minus 1 minus 3. Now R2 implies 3r2 minus r1, and r3 implies 3r3 plus r1, which is equals to minus 3 minus 1 1 0 minus 2 4 0 minus 4 minus 8. Now r3 implies r3 minus 2r2 equals to minus 3 minus 1 1 0 minus 2 minus 4 0. 3 minus 2 equals to 1. Let z equals to k. The first equation is minus 3x minus y plus z equals to 0. The second equation is minus 2y minus 4z is equals to 0. Minus 2y minus 4k is equals to 0. Y is equals to k. Substitute the y value and z value in the first equation. Minus 3x plus 2k plus k is equals to 0. Minus 3x equals to minus 3k, x equals to k. Therefore, the corresponding values of for third eigen values is equals to x3 equals to xyz equals to k minus 2k and k, which is equals to k into 1 minus 2 1. The model matrix is given by P is equals to x1 x2 x3, which is equals to minus 1 1 1 0 1 minus 2 1 1 1. Analyze the model matrix. One by under root of 1 square plus minus 2 square plus 1 square minus 2 by under root of 1 square plus minus 2 square plus 1 square 1 by under root of 1 square plus minus 2 square plus 1 square which is equals to minus 1 by root 2, 1 by root 3, 1 by root 6, 0, 1 by root 3, minus 2 by root 6, 1 by root 2, 1 by root 3, 1 by root 6. Diagonal matrix is given by T is equals to P transpose AP, then minus 1 by root 2, 0, 1 by root 2, 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 6, minus 2 by root 6, 1 by root 6 into matrix A is 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3 multiply with again P matrix minus 1 by root 2, 1 by root 3, 1 by root 6, 0, 1 by root 3, minus 2 by root 6, 1 by root 2, 1 by root 3, 1 by root 6. Diagonal matrix is 2, 0, 0, 0, 3, 0, 0, 0, 6. Now the canonical form Y transpose Ty, which is equals to Y1, Y2, Y3 into the diagonal matrix 2, 0, 0, 0, 3, 0, 0, 0, 6. Y is Y1, Y2, Y3. Therefore, canonical form is equals to 2y1 square plus 3y2 square plus 6y3 square. Index of the matrix is the index of index equals to 3 and signature is 3 and nature is positive definite. Reduce the quadratic form 3x square minus 2y square minus z square minus 4xy plus 8xz plus 12yz to a canonical form. First of all, we will consider x, y and z. X square coefficient is 3, y square coefficient is minus 2, z square coefficient is minus 1, xy coefficient is minus 4 by 2, z coefficient is 8 by 2, minus 4 by 2, 8 by 2, yz coefficient is 12 by 2, here also 12 by 2. Therefore, A is equals to 3 minus 2, 4 minus 2 minus 2, 6, 4, 6 minus 1. Therefore, the characteristic matrix is A minus lambda I is equals to 3 minus lambda minus 2, 4 minus 2 minus 2 minus lambda 6, 4, 6 minus 1 minus lambda. The characteristic equation is that of A minus lambda I is equals to 0. Now find out the net 3 minus lambda into minus 2 minus lambda into minus 1 minus lambda minus 6 into 6, 36 plus 2 into minus 2 into minus 1 minus lambda minus 24 plus 4 into minus 12 minus 4 into minus 2 minus lambda. This is equal to 3 minus lambda into 2 plus 3 lambda plus lambda square minus 36 plus 2 into 2 plus 2 lambda minus 24 plus 4 into minus 4 plus 4 lambda. Can write which is equal to 3 minus lambda into lambda square plus 3 lambda minus 34 plus 2 into 2 lambda minus 22 plus 4 into 4 lambda minus 4 is equals to 0. 3 lambda square plus 9 lambda minus 1 or 2 minus lambda cube minus 3 lambda square plus 34 lambda plus 4 lambda minus 4 44 plus 16 lambda minus 16 is equals to 0. Minus lambda cube plus 63 lambda minus 162 is equals to 0. Therefore, lambda cube minus 63 lambda plus 162 is equals to 0. Therefore, the values of lambda is equals to minus 9, 3, 6. These are the eigenvalues. Corresponding to the lambda equals to minus 9. For each eigenvalue, we will find out the eigenvectors. For lambda equals to minus 9, 3 minus lambda minus 2, 4 minus 2 minus 6, 4, 6 minus 1 minus 1 lambda, which is equals to 3 plus 9 minus 2, 4 minus 2 minus 2 plus 9, 6, 4, 6 minus 1 plus 9 is equals to 12 minus 2, 4 minus 2, 7, 6, 4, 6, 8. Where do we R2 plus 6R2 plus R1 and R3 plus 3R3 minus R1. Row 1 will be as it is. Do R3 plus 2R3 minus R2, 12 minus 2, 4, 0, 40, 40, 0, 0, 0. lambda is equals to 3, which is 3 minus 3 minus 2, 4 minus 2, 3 minus 3 minus 2, 4 minus 2 minus 2 minus 3, 6, 4, 6 minus 1 minus 3, which is equals to 0 minus 2, 4 minus 2 minus 5, 6, 4, 6 minus 4. Now R1 divided plus R2 minus 2 minus 5, 6, 0 minus 2, 4, 4, 6 minus 4. R3 plus R3 plus 2 R1. R1 and R2 will be as it is, minus 2 minus 5, 6, 0 minus 2, 4, 0, 4 minus 4, 4 minus 4 is 0, 6 minus of plus 6 minus of 10, 6 minus 10 is minus 4, minus 4 plus 12 is 8. So R3, if you observe carefully, R3 and R2 are R3 is equals to R3 minus 2R2. This is equals to minus 2 minus 5, 6, 0 minus 2, 4, 0, 0, 0. Let z equals to k. The second equation is minus 2y plus 4z is equals to 0. 2y equals to 4z, y is equals to 2z, and when z equals to k, we will be 2k, and the equation 1 will be minus 2x minus 5y minus 6z is equals to 0. Substituting y and z in the equation, minus 2x minus 10k plus 6k is equals to 0. Minus 2x equals to 4k, x equals to minus 2k. Therefore x2 is equals to minus 2, 2, 1. The third eigenvalue, lambda equals to 6, 3 minus 6 minus 2, 4 minus 2 minus 2 minus 6, 6, 4, 6 minus 1 minus 6 is equals to minus 3 minus 2, 4 minus 2 minus 8, 6, 4, 6 minus 7. R2 plus 3R2 minus 2R1, and R3 plus 3R3 . The matrix will be minus 3, minus 2, 4, 0, minus 20, 10, 0, minus 6, 3. Now R3 implies 10 R3 minus 3 R2, 3 minus 2, 4, 0, minus 20, 10, 0, 0, 0. Let z is equals to k. The second equation is minus 20 y plus 10z is equals to 0. Minus 20y is equals to minus 10k. Y is equals to 1 by 2k. From equation 1, minus 3x minus 2y plus 4z is equals to 0 plus 3x minus 2 into 1 by 2k plus 4k is equals to 0 minus 3x minus 3k is equals to 0 plus 3k minus 3x plus 3k equals to 0 x equals to k. Now corresponding to that 3k 1 by 2k k is equals to 2k k and 2k. Therefore x3 is equals to 212 into k. Model matrix P is equals to x1 x2 x3. This is equals to minus 1 minus 2 2 minus 2 2 2 1 1 2. Therefore normalized model matrix is equals to minus 1 by under root of minus 1 whole square plus minus 2 whole square plus 2 square minus 2 by minus 1 whole square minus 2 whole square plus 2 square 2 by minus 1 whole square plus minus 2 whole square plus 2 square minus 2 by minus 2 whole square plus 2 square plus 1 square which is under root 2 by under root of minus 2 square plus 2 square plus 1 square 1 by under root of minus 2 square plus 2 square plus 1 square 2 by under root of 2 square plus 1 square plus 2 square 1 by 2 square plus 1 square plus 2 square 2 by 2 square plus 1 square plus 2 square. The values are, therefore the normalized matrix values are is equals to minus 1 by 3 minus 2 by 3 2 by 3 here minus 2 by 3 2 by 3 2 by 3 1 by 3 2 by 3 2 by 3. Diagonal matrix T is equals to P transpose A P minus 1 by 3. Into matrix A is 3 minus 2 4 minus 2 minus 2 6 4 6 minus 1 into P. P is minus 1 by 3 minus 2 by 3 2 by 3 minus 2 by 3 2 by 3 1 by 3 2 by 3 2 by 3 2 by 3. By multiplying we can obtain the diagonal matrix is equals to minus 9 0 0 0 3 0 0 0 6. The canonical form is equals to y transpose dy, y1, y2, y3, d is minus 0, 0, 0, 3, 0, 0, 0, 6 into y1, y2, y3 is equals to minus 9y1 square plus 3y2 square plus 6y3 square. The index of the matrix is 3. Signature equals to 3 and the nature is positive definite. Given A is equals to 1, 4, 2, 3. Now from the characteristics equation, A minus lambda is equals to 0. Therefore 1 minus lambda 4, 2, 3 minus lambda. Delta of this matrix is equals to 0. Therefore 1 minus lambda into 3 minus lambda minus 8 is equals to 0. 3 lambda minus 3 lambda plus lambda square minus 8 is equals to 0. Lambda square minus 4 lambda minus 5. Minus lambda minus 3 lambda plus lambda square minus 8 is equal to 0. Lambda square minus 4 lambda minus 5 is equal to 0. Now the values of lambda are 5 comma minus 1. Now here the problem, in the character equation, in the lambda we can substitute lambda is equal to a. Therefore a square minus 4 lambda minus 5 is equal to 0. The given a power 5 minus 4a power 4 minus 7a cube plus 11a square minus a minus 10. Now here by taking a cube common in the first equation, we can write a square minus 4a minus 5 minus 2 minus 7 plus 11a square minus a minus 10i. a cube into a square minus 4a minus 5 minus 5 minus 2 plus 11a square minus a minus 10i. A cube into a square minus 4a minus 5 minus 2a cube plus 11a square minus a minus 10i. Now a square minus 4a minus 5 equals to 0. Therefore a cube into 0 minus 2a cube. We can write this one as 8a square plus 3a square minus a minus 10i. Taking 2a as a common, a square minus 4a plus 5a plus 3a square minus 10i. This here, this value of 0, which is 2a into 0 plus 3a square minus 10i. Here this is minus 2a cube plus 8a square plus 3a square minus plus 10a minus 10a minus a minus 10i. Now by taking these three terms, taking a square, taking 2a square as common, taking minus 2a square as common, a now in these three, taking minus 2a as common, a square minus 4a minus 5. The remaining terms are 3a square minus 11a minus 10i. Now here these three sum is 0. Therefore minus 2a into 0 plus 3a square minus 11a minus 10i. Now we can take 3 as a common, a square minus 4a minus 10i. We can write the above expression as 3a square minus 12a plus a minus 15i plus 5i. Now in these three terms, 3a square, 12a and 59, take in 3a's common, a square minus 4a minus 5. The remaining terms are a plus 5i. Again this term will be 0, which is 3 into 0 plus a plus 5i. This is a plus 5i. We know the matrix A. Matrix A is given as 1, 4, 2, 3 plus 5 into identity matrix 1, 0, 0, 1, which is equals to 6, 4, 2, 8. This is the final solution. Find characteristic roots of the matrix and corresponding characteristic vectors given A is equals to 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. The characteristic matrix is given by A minus lambda I is equals to 6 minus lambda minus 2, 2 minus 2, 3 minus lambda minus 1, 2 minus 1, 3 minus lambda. Delta of the characteristic matrix is equals to 0. Therefore 6 minus lambda into 9 plus lambda square minus 6 lambda minus 1 plus 2 into minus 6 plus 2 lambda plus 2 plus 2 into 2 minus 2 into 3 minus lambda is equals to 0. 6 minus lambda into lambda square minus 6 lambda plus 8 plus 2 into 2 lambda minus 4 మాట్లాడతాడు చెప్పండి plus 2 into minus 4 plus 2 lambda is equals to 0. 6 lambda square minus 36 lambda plus 48 minus lambda cube plus 6 lambda square minus 8 lambda plus 4 lambda minus 8 plus 4 lambda is equals to 0. Minus lambda cube plus 12 lambda square minus 36 lambda plus 32 is equals to 0. Lambda cube square plus 36 lambda minus 32 equals to 0. Therefore the values of lambda is equals to 8, 2, 2 or 2, 2, 8. These are the eigen values. Corresponding lambda equals to 2. Lambda for lambda equals to 2, a minus lambda index equals to 0. Therefore the matrix is 6 minus 2 minus 2 2 minus 2 3 minus 2 minus 1 2 minus 1 3 minus 2 into x1 x2 x3 is equals to 0 0 0. Four minus 2 2 minus 2 1 minus 1 2 minus 1 1 into x1 x2 x3 is equals to 0 0 0. Let a minus lambda high is equals to 4 minus 2 2 2 1 minus 1 2 minus 1 1. R2 implies 2R2 plus R1. R3 implies 2R3 minus R1. 4 minus 2 1 0 0 minus 1 0 0 plus 1. Now R3 plus R3 plus R2. 4 minus 2 1 0 0 minus 1 0 0 0. Let n minus r equals to 3 minus 2 equals to 1. Four x1 plus 2x2 plus x3 is equals to 0. X2 is equals to k, that is x2 equals to k, and x3 is equals to minus x3 equals to 0. Therefore x3 is equals to 0. 4 into x1 minus 2k plus 0 equals to 0. x1 is equals to k by 2. Eigen vector is x is equals to x1 x2 x3, which is equals to 1 by 2k, k by 2, k 0 is equals to 1 2 0 into k. X is equals to 1 2 0. For lambda equals to 8, 6 minus 8 minus 2 1 minus 2 3 minus 8 minus 1 2 minus 1 3 minus 8 is equals to minus 2 minus 2 1 minus 2 minus 5 1 minus 1 2 minus 1 minus 5. R2 implies R2 minus R1, R3 implies R3 plus R1. Matrix will be minus 2 minus 2 1 0 minus 3 minus 2 0 minus 3 minus 4. R3 plus R3 minus R2 minus 2 minus 2 1 0 minus 3 minus 2 0 0 minus 2. Therefore the values of equations are minus 2 x1 minus 2 x2 plus x3 is equals to 0, minus 3 x2 minus 2 x cube x3 equals to 0, minus 2 x3 is equals to 0. Therefore x3 equals to 0. Substitute this value, minus 3 x2 equals to 0. Therefore x2 equals to 0. Now substitute these two values in the first equation. minus 2x1 plus 0 equals to 0. Therefore x1 equals to 0. X is equals to x1, x2, x3 equals to 0, 0, 0. Therefore eigenvectors x1 is equals to 1, 2, 0, x2 is equals to 0, 0, 0. Verify Cayley-Hamilton theorem for a matrix A, where A is 3, 4, 1, 2, 1, 6, minus 1, 4, 7. Therefore, the characteristic matrix will be 3 minus Jj minus lambda I. 3 minus lambda 4, 1, minus 2, 1 minus lambda 6, minus 1, 4 is equals to 0. Therefore, its that will be 3 minus lambda into 1 minus lambda into 7 minus lambda minus 24 minus 4 into 2 into 7 minus lambda plus 6 plus 1 into 8 plus 1 into 1 minus lambda is equals to 0. Which is 3 minus lambda into lambda square minus 7 lambda minus lambda minus 17 minus 4 into 20 minus 2 lambda plus 9 minus lambda is equals to 0. 3 lambda square minus 24 lambda minus 51 minus lambda cube plus 8 lambda square plus 17 lambda minus 71 plus 7 lambda is equals to 0. Minus lambda cube plus 11 lambda square minus 122 equals to 0. Therefore, lambda cube minus 11 lambda square plus 122 is equals to 0. So, by substituting lambda equals to a, this will be a cube minus 11a square plus 122 I is equals to 0. We know that a equals to 3, 4, 1, 2, 1, 6, minus 1, 4 and 7. Therefore, a square is equals to 16, 20, 34, 2, 33, 50, minus 2, 28, 72. And the value of a cube is 4, 220, 374, 22, 241, 550, minus 22, 308, 670. A cube minus 11a square plus 122 I is equals to 0. So substitute the values of a square and a cube in this. We can find, right? A cube is 54, 220, 374, 22, 241, 550, minus 22, 308, 670, minus 11 into a square is 16, 20, 34, 2, 33, 50, minus 2, 28, 72, plus 122 identity matrix 1 0 0 0 1 0 0 0 1. Now if substitute the values, we can obtain null matrix 0 0 0 0 0 0 0 0 0. To find A inverse, from the above we know that A cube minus 11A square plus 122I is equals to 0. Multiply on both sides with A inverse. Its value is A square minus 11A plus 122 A inverse is equals to 0 into A inverse. 122 A inverse is equals to minus A square plus 11A. A inverse is equals to 1 by 122 into minus A square of 16, 20, 34, 2, 33, 50, minus 2, 28, 72, plus 11 into A matrix is 3, 4, 1, 2, 1, 6, minus 1, 4, 7. Now we can obtain the value of A inverse is equals to 1 by 122 into 17, 24, minus 23, 20, minus 22, 16, minus 9, 16, and 5. This is the inverse matrix. To find out A power 4 from, we already know that A cube minus 11A square plus 122I is equals to 0. Now multiply with A on both sides. Both sides. A power 4 minus 11A cube plus 122A is equals to 0. A power 4 equals to 11A cube minus 122A. We know the values of A cube and A. Now substituting 11 into A cube value 54, 220, 374, 22, 241, 550, minus 22, 308, 670, minus 122 into A is 341, 216, minus 147. 228, 1932, 3992, minus 2, 2529, 5318, minus 120, 2900, 6516. This is the value of A power 4. The characteristic equation is that of A minus lambda I is equals to 0. For that of 1 minus lambda 2, 2 minus 1 minus lambda is equals to 0. 1 minus lambda into minus 1 minus lambda minus 4 is equals to 0. which is minus 1 plus lambda minus lambda plus lambda square minus 4 is equals to 0. Lambda square minus 5 is equals to 0. Therefore, lambda square is equals to 5. By Cayley-Hamilton theorem, a square is equals to 5a. We need to find out a power 8, which is equals to a square whole power 4. Place of a square, you can write 5 by whole power 4 is equals to 5 power 4 into 5. 5 power 4 is 625 into 2 by 2. Identity is 1001 is equals to 625 0 0 625. This is the value of e power 8.